Hello, today you get to enjoy my deep and gravelly voice. We are going to talk about percent error. I'm not going to go through all of the exciting questions that we discussed on Tuesday, but we did find out that almost 100% of you have fallen asleep in a class, so important information for all of your teachers to know. Thank you for sharing that. Unsurprising, actually. So I'm going to just use the Six Flags example here. If you had, for example, 20 people in your class, and you predicted, I think out of those 20 people, I think that's 17 people have been to Six Flags. And then we did the vote, or the measurement, and we found that actually 19 people have been to Six Flags. Then my question for you would be, how far off are you? And there's two different ways you can talk about how far off. You can talk about it in absolute terms, just how many people off are you. But you can also talk about it in percent terms, comparing it to that actual amount. So yes, you were 2 people off, but what does that mean when there were 19 people who actually had said that they've been to Six Flags before? If we're talking about the absolute error, that's like when we talked about absolute change on Monday. That absolute error could be found by subtracting. 19 minus 17, you are 2 people off. 2 people off would be really good if there were 100 people. 2 people off, maybe not so good when there are 17 people. 2 people off would be really bad if there were only 4 people. That's where percent error comes in. So we've got that there were actually 19 people who said that they had been to Six Flags, and you have an error of being 2 people off. You can use the tools that you already have in terms of percent equations and or percent bars to talk about what percent of that 19 people were you off by. So your 2 people off would be your part. The 19 people actually who went to Six Flags would be your whole. So we have a part to whole relationship, and you could use that to find your percent. And since we were working with gnarlier numbers this time, I was okay with people using calculators, and that let us talk about how you can use a calculator to find a percent. Knowing that this fraction bar works like division, a lot of people were able to say, well, I could do 2 divided by 19. If I did 2 divided by 19, I would end up with a long decimal that obviously I would want to round at some point. And let's talk about it just to the thousandths place. So 2/19 is approximately 0.105. And some people ask me, what are those squiggly equal signs? That means that it's approximately this, because it actually goes on forever. It is not exactly 0.105. But if I want to turn that into a percent, I need to pay attention to the hundredths place. And in this case, that 0 is in the hundredths place. So I'm going to pay attention to this number after it, that 5. Is that going to round me up so that this is a 1, or is it going to keep me at 0? And we know by convention, if it's 5 or above, we're going to round this number up. So that would make this approximately 0.11. You know I don't love saying 0.11. I'd rather say this as it would be said as a fraction. This would be 11 hundredths. And the reason that's really helpful here is because 11 hundredths gives you your percent. 11 hundredths is 11%. Meaning that my percent error was 11%. I was 11% off from the actual number of 19 people. Once again, using what I know about part and whole, I'm able to apply it to a new situation, just like we did when we were talking about percent change. Got 2 problems that we can talk about on the back that involve percent error. First one was a dance situation. At the Frozen Dance, the 8th grade organizers predicted that 100 students would show up. 125 students actually came. What was the percent error for their prediction? So they predicted 100. The actual was 125. So they were shy, they were low, and there were 25 students low. we're 25 students off. 25 off could be really bad if you had very few people. It could be okay if you had a lot of people. Let's think about what that then is in relation to 125. Like, actually, how good or how bad of a prediction was that? So 25, we're relating to 125 because that's our actual. And I had people who wanted to go to a calculator immediately, but you don't need to. You already have the tools. If you have 25 over 125, you could reduce that fraction. Divide by 25 in the numerator and the denominator, and you would end up with 1/5. You may already know what 1/5 is a fraction, or what it is as a percent. I'm going to go through how you could get it to a percent. We need to get it to 100 in the denominator. So that if I multiply the numerator and denominator by 20, I'm going to have 21/100ths, which is 20%. Those 8th grade organizers were 20% off. Not as bad as 50% off, not as great as if they were 7% off. And then I ask, what if only 90 students actually came? So now our prediction was 100 and our actual was 90. 100 minus 90 is only 10 students off. That looks like it's better because it's only 10 students off, but let's compare it to this smaller number of students who came. So we can compare our 10 off to the 90 actually, which would be 1/9, and 1/9 is approximately 0.11 repeating, or 11/100ths, or 11%. So in fact, this was a better prediction given that 90 students came. They were closer to what the actual number of students in attendance was. With all of the labs that you did, we saw that when you're measuring, you want to be precise. And the lower your percent error, the better it means you've measured something or you've predicted something. Goodbye.